and for sticking to the time limit. And I'm calling Mr. Suklang Kharnaior from Department of Biosciences, Assam Bosco University from India, to present a review on Aquilaria malaccensis propagation and production of secondary metabolite from Callus. Please, Ms. Kharnaior, are you with us?
Here?
Yes? Hello?
Is it audible?
We can hear you, we can't see you. Okay, now we can hear and see. Please share your presentation with us.
Greeting to everyone. I'm Suklang Kharnaior, PhD scholar of Assam Bosco University. So before I start to present my research topic, can I request, can I off my camera because the internet connection is a little bit fluctuating. Hello, is it audible?
Yes, it is.
Okay.
Everything is okay.
Yeah. Can I off my camera because it's a little bit fluctuating in the internet connection?
Yes, please do.
Okay, thank you.
It might help.
Is it audible?
Yes, it is.
These are the contents that we're talking about. That is the introductions, the economical value, the propagation of Aquilaria malaccensis, the secondary metabolites production from the Aquilaria malaccensis, and the future aspects. Well, I would like to introduce first what is this Aquilaria malaccensis. Aquilaria malaccensis is a fragrance on timberwoods which belongs to the family Thymilaceae, and it is commonly known as agarwood. And it is one of the most costly wood in the world, which has a highly demand in the market value because of its fragrance compounds which are obtained from this species. Therefore, the species become overexploited and it affects the availability in the natural habitats. Therefore, in 2004, the species was listed as an endangered species in Appendix 1 and Appendix 2 of CTIS. And in India, there are 3 endemic species, that is Aquilaria khasiana, Macrophylla, and malaccensis. Hence, conservation, propagation, and final and alternative methods for the production of a unique secondary metabolites are urgently needed. Therefore, the objective of this paper is to compile the major research work on the conservation and production of secondary metabolites. This is a 3-year-old Aquilaria malaccensis tree. The flowers, fruits, immediate and immediate seeds. And what are the economical values which are obtained from this agarwood? There are three main principles. That is, one is perfume, incense sticks, and pharmaceutical use. Traditionally in the Middle East, it was observed that the agarwood oil and smoke which are obtained from this agarwood tree is being used as a scent, and it's also used by many religious practices. And agarwood fragrance is also being employed as an aromatic gradient in detergents like shampoo, soap, etc. And several researchers were also trying to synthesize the aromatic compound which are obtained from this from the agarwood tree, but there are some mismatch, or there are something which is not connected with that compared to the natural value. Therefore, the quality of the oil which are obtained from the synthetic agarwood aromatic compounds is low. And when it comes to incense sticks is a sticks which are coated with fragrances, where where it has a significant amount of accounting, prayers, religious practices, purposes, and some like insect repellents. And they think that these incense sticks, which the incense stick is the perfumes or the scents which are coming out from this, it brings luck and safety to the believers. And it was also reported that the incense sticks, which are the incense stick quality of the Indian and the Chinese, has dropped down. As reported, the agarwood concentration is less as they may have replaced with their synthetic oil. And the pharmaceutical use, as we all know, that many plants or herbs, they are traditionally used to treat various diseases. As this agarwood is one of them, like to treat pleurisy, relieve pain, arrest vomiting, and asthma. And they have also tried to check the differences, the differences in the medicinal value of infected wood and of uninfected wood and the infected wood. And they have been found that the infected wood are used for treat jaundice and body pains, whereas the infected wood has more quality for the medicinal values, like for treating of various diseases, like it has an anti-cancer, anti-diabetic, etc. And in 2015, the Ayurvedic department, they have trying to do a research on this agarwood tree, and they have found that the medicinal compounds which are obtained from this agarwood has various medicinal values for treating like appetizer, analgesic, antipyretic, antihistaminic, styptic, carminative, cytotoxic, insecticidal, generatoxic, generatonic, etc. And why this? Since like I've already talked, like this species, it's an endangered species. Therefore, propagation and conservation of this species is very important. So therefore, like traditionally, like for the mass production of Aquilaria malaccensis, they have been done by grafting, stem cutting, and seedlings. But due to some external factors, these traditional practices, it's not benefiting or it's not help them to increase their economics and to reach the demands in the market. Like one of this the environmental factors is like the seed. It has a very low shelf life, which is ranges from 15 to 40 days, and therefore to enhance the traditional method, stem cutting was developed by treating the injured stems and various concentration of endobutyric acids for rooting development. And therefore, like a biological technique has come to improve more than traditional methods. Like for propagation, like there are two methods. One is direct and one is indirect methods, organogenesis, and direct methods, organogenesis. Indirect methods is like production of a callus or organogenesis from small tissues like callus from a callus. And it has been reported that the media supplemented with BAP, NAA, BAP, NAA, 240, and kinetins. It helps to produce more optimal production of callus. When it comes to the direct organogenesis, where in this direct organogenesis, the medium you're using is MS medium, where it been supplemented with a BAP, a TDZ for the shoot development, and they are being using from different parts of the plants. And for the roots, they have observed that a half strength of the MS medium containing IPA, it shows more induction. And direct organogenesis was also obtained in a medium with high concentration of BAP and low concentration of NA, where roots was developed in a half-strength medium with NAA. Therefore, due to this low shelf life of the seed, in 2018, an artificial seed was developed by encapsulating the nodal bud with 2.5% of sodium arginate and 100 millimolar of calcium chloride. Since like I've already talked, like the should find another alternative methods for the production of the secondary metabolites to meet the demand of the production of unique fragrances. Therefore, in 2009, it's been studied that the two major compounds which are obtained from the callus are sesquiterpenoids from the living cells and chromones might generate from the dead cells. And was conducted a study to enhance the mechanism of how plants and microbes interactions are taking place. In these studies, they have found that the callus, they have studied on the callus, the juvenile plants, and resinous wood chips infected with fusarium. These are the future. The last would be the future prospects. The in vitro techniques determine an alternative source for agave production for mass callus of Aquilaria species, although the callus induction using leaf, nodal, and shoot plants are reported by various researchers. Other parts from the vegetative and productive phase are also might be the best extent. And it has not been reported so far from the production of planters or organogenesis from the callus. A further research is highly recommended to improve the in vitro and in vivo methods for the mass production of Aquilaria tree. As reported by various researchers, callus impersonate has significant characters in the production of secondary metabolites. For further studies, a comparative study could be done for the isolation, identification, and classification of microorganisms to give a better insight on the plants and microbes interactions.
Thank you very much. We'll have to conclude. Yes. Thank you very much, Mr. Kharnaior.